This video is on functions. We're going to determine if these are functions or not. So we have functions, yay or nay. We're going to be looking at graphs, and we're going to be looking at table or input-output diagrams. So for graphs, we're going to look for the vertical line test. For tables, we're going to be looking at the x values to make sure that it only has one y value. So our first example, we're going to tell whether the following are functions or not, and we're going to explain our reasoning. So the first one is a graph. That means we want to check the vertical line test. We draw a vertical line, and we can draw as many vertical lines as we need to, but we want to go through the graph itself. So this is our graph. It's an oval shape. If I draw a vertical line down here, the vertical line crosses twice on this oval, so that fails the vertical line test. This is not a function. Because and the reasoning for it is it does not pass the VLT. So that's that vertical line test. Does not pass the VLT. If we go to the second example, we have a graph again. We want to draw a vertical line, but again, we want to draw a vertical line where the graph is located. So our graph is located in quadrant 1 and 4. So we draw a vertical line, and if this vertical line, as you can see, it crosses twice, and on that same vertical line, the graph will cross two different locations. So this also is not a function because, again, it fails the vertical line test. So this is not a function, and I'll put it fails the VLT. Failing is the same thing as not passing. If we go to our next example, we again have a graph. That means we're going to look for a vertical line. So over here, we don't want to do a vertical line over here. There's no graph. So I'll draw a vertical line over here. Our graph only crosses this vertical line once. And if I were to draw more vertical lines all the way through this, we will be able to see that it will only cross each vertical line once. Doesn't matter how many vertical lines I do, it will still only pass through the vertical line once. That means that this is a function because it passes the vertical line test. Our next example is a table. Our table, we look at the x values. If every x value, basically we don't want to have repeating x values. If you see here, we have a 5, 3, 5, 7. We have a 5 two different times. That does not automatically mean it's not a function, but it tells us that we need to recheck the y's. The y's do not matter if the x's are good, but because the x's are not good, we must check the y's. So with this first 5, the y value is -1. So I'm going to highlight that in pink because that yellow 5 and that pink -1 go together. On the other yellow 5, I want to look at that y value and see if I can highlight it in pink as well. Pink was the -1. This y value is a +1. That is not the same. I cannot highlight it in the same color. Because these values do not match up 100%, this x value of 5 has two different y values. That means that this, again, is not a function. Not a function. The reason behind this is that x equals 5 has two different y values. It has a y value of -1 and a y value of +1. What that means is that if I were to graph this of, let's say, like x equals 5, if I just graph it on something over here, 1, that's 4, so that would be 5. I would have a point at 5, 1 and 5, -1. I could draw a vertical line through that. That's not a function. A vertical line is not a function because it would not pass the vertical line test. On this next example, we again have a table, so we look at the x values. We have -2, 0, +2, and 0 again. So we again have repeating x values. I'm going to highlight those, because those are the repeating values. And then we look at the y's for them. So this first 0 has a y value of 2, +2. My next x0 has a y value of +2. These are the same y values, so I can highlight this in pink. Now, because this coordinate, this x value has a y value of 2, and the same x value has the same y value of +2, this actually is a function. Because the definition means that each x value has only one y value. This is the same x value, but it has the same y value. So each of these x's still have only one y value. So our reasoning is each x value has only one y value. Now in this case, it's because the coordinate, that point, actually repeats. That the point repeats. The x values, if they repeat, does not automatically mean not a function. You have to then look at the y values to see if those also repeat. So if the entire coordinate repeats, you only have to graph that once. I wouldn't draw a vertical line through that, or it would only still cross once. So that would still pass the vertical line test. So you always have to look to see, are the y values also repeating with the repeating x values. On this last example of determine if it's a function, we have an input-output table. So the input is still your x values. So our x value of 5 goes to -15. The x value of 6 actually has two arrows coming off of it. So this would be a 6, 3 and a 6, -2. So that would be the same thing as the table where the 6 is repeated. But again, just because the 6 is repeated does not mean it automatically is not a function. We look to see what does the 6 go to. It maps to the +3, but then it maps to a -2, which is not the same. Because these are two different values, this will not be a function. We do not even need to look at this next coordinate because we already know it's not a function. This is not a function because that x equals 6 has two different y values. Now this is also saying that the input of 6 has two different outputs, but the input is generally known as the x's and the output is generally known as the y's. So this is how you can tell if a graph or a table is a function or not.